Hi friends, welcome back to another episode of Making Things Fun, Cool, and Sexy. I'm your host, Christine Hollino, and today we're diving into an exciting topic that's changing the game for small and medium-sized manufacturers: automation and robotics. This episode features a special panel I moderated at the AMBayArea Winter Forum titled Automation for SMBs, Starting Small. I had the honor of speaking with industry experts, including a representative from Google's robotics startup, Intrinsic AI, about how SMBs can embrace automation without the heavy price tag or complexity we often assume comes with it. If you've ever wondered how to get started with automation or how robotics can fit into your manufacturing processes, this episode is for you. Stick around for actionable insights and real-world examples that prove automation is easier and more affordable than you think. Let's dive in.
Hi everyone, Alex Huckstep. I am currently the co-founder and chief commercial officer of Uptool, which is a company I founded less than a year ago, about 10 months ago, so still very new. I'll tell you a bit about my background and then tell you a bit about Uptool. So background in mechanical engineering. I've spent most of my career leading kind of commercial go-to-market teams for various manufacturing tech startups, many of which here in the Bay Area. So some 3D printing startups, two most recently robotic manufacturing startups, one in Berkeley called Aris, one in LA called Makina Labs. And 9-10 months ago now started Uptool, where we are on a mission to really modernize small high-mix manufacturing through really intelligent, highly automated, using a lot of AI, of course, to help small high-mix manufacturers handle kind of the end-to-end workflow, starting with quoting and making that go a lot faster so that manufacturers can win more business, quote more accurately. And then we'll be going downstream until we have sort of what looks like a full ERP and an end-to-end solution.
Hi everyone, my name is Simon Napiri. So I lead partnerships and business development at Intrinsic. Intrinsic is a Google company. We're a fully owned subsidiary of Google. So you may be wondering, what is Google doing in robotics and automation? We're basically trying to solve the problem of flexible automation. As you know, the repetitive automation, where the robot does all the time the same thing again and again, has kind of been solved already. So now the next frontier is to go into high mix, low volume, like what you just mentioned, Alex, non-repetitive, flexible. And to do that, you need a lot of advanced AI. And so that's what we try to do, being part of the Google family, is to bring this AI into your operations. Before that, I was an AI and robotics system integrator, also based in the Bay Area. And we went Hayward, it was called Vicarious. And we were more focused on logistics, so killing, palletizing, bin picking. Also with this AI angle to try to do non-repetitive automation, flexible automation. Then we got acquired by Google, so that's how I came along to Intrinsic.
Hi, my name is Tim DeGrasse. I'm VP of Sales for Applied Engineering. We're a local build-to-print system contract manufacturer in South San Jose. I've got a background in a variety of different robotics fields, so I studied robotics in school. And then most recently, I worked for a company called Universal Robots, and that pulled me over to Applied Engineering. We get involved in many different types of applications in many different fields, and a lot of different kinds of robots flow through the house. And so, yeah, definitely honored to have the opportunity to talk about robots today. It's a passion of mine, and see if we can help people start automating.
Hi, my name is Krishna Rajagopal. I'm probably the odd person out here. I owned a manufacturing company in Chicago, ran it for about 15 years, sold it in 2015. But our claim to fame was we did about 200 million in revenues with 50 people, right? So that was our claim to fame by automating everything. So we had tracking of product with our customers before FedEx had it, right? So we spent a lot of time automating processes and systems. I own a consulting company here, which has a small VC fund and also a private equity fund. So hopefully we'll have a great day today. And on a side note, I'm also the board chair for AMBayArea.
Awesome, thanks guys. So before we start, I want to ask all of you, who has robotics or automation in your factories? All right, impressive. Well, how this panel came about was after attending IMTS last year. It's one of the largest manufacturing conferences around, and it's in Chicago. I came back so excited. I told AMBayArea, oh my goodness, so many robotics, so much automation, and it's actually very affordable now. You know, you could find pallet systems for under 200,000, you can find robots for under 100,000, but where do we start? Where do we even start with robotics? How do we incorporate some automation into robotics, into our factories? And I think like many other manufacturers here, we don't know where to start. So what better way than to gather a bunch of experts in Silicon Valley within the automation and robotics industry to learn from and then share it with our AMBayArea members. So Alex, you had posted on LinkedIn this graphic, and I was appalled because apparently of all the robots in the world, 51% of the robots are in China. America is at 7%. We are so far behind. Can you share a little bit more about this?
Sure. Yeah, so, I think I'm also shocked by it when I first saw how sort of far behind we were. I think that especially when you factor in our labor rates, right? And our massive shortage of skilled workers in terms of all the open positions, you would think that like the U.S. of any country should be kind of installing more robots than anyone else. And so clearly we're kind of falling behind in terms of our levels of automation. And maybe we'll talk a bit more today about kind of what we'll do to fix that.
Yeah. So first things first, where do we start, and what should small and medium manufacturers figure out how to add automation into their factories? And we'll just go down the line.
All right, so a good place to start is probably what's easy to automate, right? So the very highly repetitive workflows. But the chances are either you already automated them or you don't have any of these, right? So what's most likely to be left is things that are more high mix low volumes. So these are the hard ones to automate. Within these ones, a good place to start is maybe high mix, but that's a problem that you may not be the only one to have. For example, tending machines. If you have a CNC machine, let's say a lathe or a mill, you're likely to not be the only one to have that problem. So there are likely to be more solutions there that can help you automate this problem. So if you have a laser cutting machine, injection molding machine, lathe, mill, CNC machines, the machine is usually always the same. That's a good place to start thinking of other providers in my network at MTS who can help put a flexible automation in front of that. So that's an idea of where to start.
I think one of the things that people forget is, right, you have the administrative side of things that can also be automated, right? So when you start looking at back office functions, it's very easy for us to forget that there are people involved that are doing repetitive tasks that technically can be automated. I'm not sure how many of you guys use ERP systems, right? But if you're using ERP systems, our experience has been that you're probably using only 5% of its capability. So the question is, how do you go to the point where you're using 90, 95% of that capability? And the amount of efficiency that you gain is tremendous because, the idea is that when companies are growing, especially small companies, they tend to add people as an easy fix, as opposed to saying, can we invest in a process or a system to improve, right? So it's just shifting your mind a little bit, right? So that's where, you think of automation. Everybody looks at the machine, but it's also really important to look at the process and figuring out if it's worth, automating or not.
Yeah, no, that's a very good point. One of the places you can start looking, a common word that we would use is the 3D, so dirty, dull, or dangerous. Most people, when they look at automation, they always go towards, like, what's the hardest task in the factory? And that's actually a really difficult place to start because robots are a lot less, intelligent than we might think. People were amazingly creative, eyes and fingers and brains. And so I always recommend maybe reach out to a solution provider, somebody who's, swum in the world of automation for a long time, like Trinity Robotics or Intrinsic. And, they can walk your factory floor and help you identify where the right areas to automate are, where there's good ROI, and help you get on a journey of sort of crawl, walk, run. So maybe start off with one automated system. And if it all goes well, it turns into a little ATM machine on your factory floor, right? It just helps you increase productivity, decrease failures. It runs overnight. You come in after a long weekend and your box is full of nice parts. And so once you start investing in automation, if all goes well, it should really snowball. And maybe you'll end up like Krishna here with 200 million and only 50 people. So, he'll give coaching points along the way too.
Maybe just one other quick dimension to add to this. So at Uptool, we've spent like the last year basically with just learning as much as we can from a lot of different mostly local, small high-mix manufacturers. And what we've seen that's really working to their benefit are probably the biggest thing is on the physical automation, robotic automation side is pallet loaders, pallet changers. We've seen a lot of shops installing those over the last few years, and we've seen a lot of shops that are able to continuously run parts through the weekends, which is a huge game changer. And then the other one is cobots too. I think we're seeing more and more adoption of cobots in high-mix environments because they don't take as much programming or skill or time investment to sort of learn and participate in a new task. And the other area just to think about is just the 3Ds is great, and also though where are you bottlenecked? Where are you maybe spending a lot of overtime labor or any of those tasks potentially sort of simple, repetitive, that are a good fit for automation.
That's perfect. And it goes into my next question. So there is a myth out there, and people like my father will say, we cannot add automation or robotics because we're not a production shop, meaning we're making thousands of units repetitively. Most shops in Silicon Valley are prototype shops. What they're saying is high mix, low volume. So guys, is that true? Do we have to have production in order to add robotics and automation, or can it be a prototype shop and it still works?
Yeah, no, great question. I think that's maybe why the pallet pull solution is so nice and innovative, because you can have the same automated cell and fixture, but put totally different parts on every night, right? So you can spend the day programming, load up your machine, push go home, and then you come back the next morning and you've got a totally different run of parts that you had the day before. So that pallet pull technology actually, I think, fits really well into the high-mix, low-volume Silicon Valley.
I think people are misguided or don't understand that the cost of automation has come down significantly. You have a lot of these machines that are capable of, they have sensors, right? The question is, how do you take the data from the sensors and use it that is meaningful? And most companies don't take advantage of that, right? So if you had a controls engineer or an electrical engineer come in and start saying, okay, hey, let me evaluate this machine and see how the information that is being generated from the machine can be put into my systems so that we can make decisions to run the business a little bit better, is where we are at, right? Ultimately, as a business, we're in the business of making money and trying to figure out how to make it cheaper and faster, right? So it doesn't necessarily mean that you have to spend $1 million, right? That was the case 20 years ago, right? But right now, it's pretty inexpensive. You can go as far as having little, bots that run around and run your reports. It generates your metrics. It's pretty amazing what is out there at a very inexpensive cost point.
To do high-mix low volume, because your parts change so frequently, you don't have the luxury to fixture anything, right? So if you cannot fixture, your robot needs to do 4 things. It needs to detect the parts, which is a new one. It needs to grasp it, it needs to move, it needs to insert it somewhere. To do all these 4 things in a way that doesn't have to be reprogrammed each time, you don't have to call your system integrator every time something changes, you need AI in each of these 4 steps. I think Krishna, you said 20 years ago it was not possible. I would even say 5 years ago, it was still a bit hard. But a lot of progress has been made, and I think we're really at the inflection point where these 4 steps can now be done in a way that's automated, at a cost-competitive way. And so that opens the door to a lot. And so, to answer your question, Christian, the easy repetitive task, it's all new, that has been done already. Can we move into prototype shops? I think so. I think we're right at the cusp where it's going to get possible.
You're working on some cool technology on that right now.
We are, and others in this room, in this panel. It's the type lift all boats, right? And advanced reduction in the cost of the hardware, advanced in the software, advanced in the cameras, advanced in the sensors. All this convergence, reduction in the cost, storage, and compute, all these trends are converging to enable this flexible automation.
Just quickly to add to this, we often draw this distinction between prototype and production work, but one usually leads to the other, right? And if we can get very efficient in doing high mix or low volume prototype work, then through automation and other means, then often that can lead to production, right? And if you've already put in a lot of the effort to automate even lower volumes, then you're very well positioned to win that production business and have it be very profitable.
So for all of you, most of you are manufacturers. So in manufacturing, let's say we get a prototype job, right? A customer will give us maybe 5 parts, 1 to 5 parts to just test. And then if it works out, usually they'll go overseas to buy the 1,000 unit order, right? Because it's a lot less expensive. So what the guys are saying here is if we can learn how to add robotics and automation now and to win and be more effective with prototypes, then we could win the bigger contracts and kind of win overall within manufacturing. Another fear is that robots will take away jobs, right? And so in my shop, if I throw out the word robot, some employees get really afraid because they're like, no, we don't want that because it's going to take all of our jobs. And that's the media, the government, they've also implanted that into society that, robots are bad. Can you guys speak on this?
I can take a stab at it. I think as business owners or managers or leaders in the company, right, I think it's really important to be transparent in the way you work with your employees, right? It's important for them to understand that if the business is not successful, the business doesn't exist, right? So it's a question of how do you get buy-in from the employees. They take an active interest in improving how you run your business. And when it comes to problems, right, the people who are doing the work actually know what the problems are. It's a question of how do you listen, hear, and figure out how to solve the problem, right? And it's really important for the people to be involved when you're bringing technology in. You can't just bring in and say, it's an edict. It works, but as soon as you're gone, everything stops. Human beings are extremely smart, right? So they do things the way they feel like doing and that they think is best. The question is, how do you get their buy-in, And, I always say, a business is easy if there were no people, right? But if you have people, you need to figure out how to work with people and get them involved in an organization to be successful.
I think that's a good point. And just to build on that, you look back at history, right? And every time there's a sort of technology shift, you have to adapt to compete, to Krishna's point. And I think having a very open, transparent conversation with your employees about how investing in new technologies is uncomfortable and requires adaptation, but ultimately that allows you to compete and profit and win and grow, and that actually then makes that career path with your employee base sustainable and gives them a lot more opportunities too. You look back at farming, right? And if you decided that tractors weren't for you and you were going to keep manually farming, those businesses didn't last very long, right? If you look back at manual lathe and mill operators, right? If they decided that CNC, they weren't going to learn that, there's still a few of them around, but right, it's a pretty small market. So I think you have to think about the long term here and just having the right kind of conversation.
Yeah, and that's actually the paradox. By investing in automation, you make yourself more competitive. So you can actually bring back more activity. With more activity comes more jobs. I think it's no secret that a lot of the manufacturing activities are outsourced and offshore to lower cost countries. I think everyone is aware of that. And so the path to reverse that trend is through increased competitiveness. And we're not going to be more competitive by lowering the salaries. That's not the way to go. We're going to be more competitive by having more technology. So that's the paradox. The other thing I would say is, everything I've observed in the industry, whenever I walk the floor of a factory or warehouse, it's never been about replacing people for the job. It's always been about filling some missing position because there's labor shortage. It's always been the way the problem was positioned. And so, yeah, the way to handle these labor shortages that have no reason to get better over time, by the way, is also through more automation.
Yeah, I always like to go onto Indeed and just type in open manufacturing jobs. And it's in the US, it's, I don't know, it hovers somewhere between 250,000 and 500,000 open jobs in manufacturing. And these are jobs that, you know, people would love to hire for. And so the problem isn't always, you know, thinking about robots stealing jobs. It's how can you actually keep up? And this is where automation jumps in. Another nice thing about looking at the dirty, dull, dangerous tasks is you'll actually see people on your floor enjoy the robot. If you have the robot do the jobs they don't like to do, they'll name the robot, they'll thank the robot. It's like, okay, I hated doing that. If you have the robot trying to do the coolest, most interesting job, you know, it might get a wrench thrown at it at 3 a.m. on the night shift. So, you know, the dirty, dull, dangerous place is a nice place to start because it helps people kind of see the beauty of automation. And yeah, your story about the tractors, I thought was interesting. Because yeah, people are terrified of tractors, right? Tractors are going to steal all the farmer jobs. And in some ways, they have shifted that. And I just see it as part of the growth of society. I mean, 20 years from now, there's going to be a litany of jobs and careers that people had never heard of. You know, when everyone was tending their own farms, no one had ever heard of an app or an iPhone. And so when you start changing these, you know, repetitive tasks and freeing up the human creativity, we actually grow as a society. So anyways, yeah, good question.
Yeah,
and I think it's also an opportunity to skill build, right? So it's about, you know, as you decrease cost, it's dollars that you can reinvest in your employees so that, you know, and that is a big advantage, right? Because they know your business, they care about your business, and now you're helping them grow and develop their careers. Right? Most people are afraid because they think they're going to lose their jobs. What you have to look at is how do you change that mindset. No, it's not. You're not going to lose your job. You're going to have something better to do and take advantage of that.
Totally agree. You know, I hear stories of like the pallet system, like what Alex is saying. There's shops that use the pallet system. They run overnight. They consistently use it. And then I hear other shops where they're like, no one touches it, right? And because it's up to the leader and the owner of the shop. Like, are you educating them to use this technology appropriately? So it really comes down to like, how are we educating the employees on how to use the technology? And we have to do it in a way where they don't want to sabotage the robots, right? So there's just so much that goes on into like adding automation and robotics. And like I was telling you guys, so I just went to CES and Tim and I had a conversation about agriculture and how a lot of automation is going into that. John Deere, I think they came out with like 4 tractors, autonomous driving. You no longer need a human on the tractor. Also, I interviewed Ava. They do LiDAR technology and they're working with a truck, also autonomous, no more driving needed. And it's all of this automation, robotics, AI, it's not to take out the jobs, right? It's to empower more humans to upskill, to uptool, to just become, to have like more advanced jobs. So I don't think there's anything to fear with the robots. We actually have to get into it fast because if China's doing it, South Korea is doing it, and they're very, very efficient within manufacturing, we really need to learn how to do it here in Silicon Valley. Having said that, you know, like I said at IMTS, pricing of automation and robotics has gone down quite a bit. How much is it to invest into automation and robotics, guys? Like, where do we start? How much is that initial cost?
I think that's a pretty broad question. So if you look at an ERP system, for example, right, it's $10,000 for a pretty robust one for a small company. That's not a lot of money, right? While if you're going to SAP, you're talking in millions. So you have to look at technology that is appropriate for you. And it's not a one size fits all. It has to be very specific. If you're looking at part carrying machines or automated tool changers, if you're looking at a CNC machine, you can get one for $25,000 or you can get one for $1 million. But it all depends what your application is. Right? So it's an extremely broad window.
But you can do it within even a $10,000 investment, right? Okay.
So since I spend my life in this kind of software world now, so you can buy an ERP potentially for $10,000, but I think the true cost from what we see is the cost to implement it, the cost to configure it, and then the cost of maintaining it and using it. And that can really add up if you do it right, or you do the 5% thing like a lot of shops do, and you get out a little bit. But that's the sort of dynamic that we're trying to change with a lot of software automation. But yeah, it doesn't mean that it's not worth investing in the right software and hardware tools today.
Yeah, so I think you're right. There's a wide range. Let's try to give some of the order of magnitudes. I think Christine, you mentioned at the beginning of that pallet system below 200K, direct workpiece assembling below 100K. Things that wouldn't have been possible a few years ago. What's probably important is to make your calculation. What is your payback, right? Within how many months or years would you have your payback? And what we observe when we sit with customers and we do business case with them is a payback within 1 year is realistic, right? So that may be a good number for you to keep in mind, 12-month payback. And maybe some of you will think, hey, it's actually still not good enough, and fair, means we need to work even harder in the industry. But there's a lot of companies for which 12-month payback is really good, especially if they cannot find the labor, as we just said before.
Yeah, I was going to touch on the same point as far as ROI. So if you look at the automotive industry, when they first started adopting robotics, at least what I've been told is the ROI was around 7 years. So you'll see auto body styles, they don't change very often because they needed those robots to run for 7 years to get amortized properly. But yeah, now you see the ROI drop under 2 years, down to 1 year. I had a customer at my former role where it was a really well-placed application, and the guy said, man, this ROI was over the weekend. And it wasn't because of the labor that was replaced, it was because of the problem that was solved. Being able to actually run this over the weekend while other things were happening solved a $100,000 problem. And so I think the ROI perspective is the right way to look at it. Because once it's paid off, everything else is just profit, right? You kind of turn your automation into that little ATM machine for your factory. So yeah, anything under 2 years is pretty good. 1 year, I've never seen a business owner hesitate in a 1 year ROI investment. The other side that's interesting is financing. A lot of people are starting to get creative, like robots as a service financing. So if your automation is saving you $1,000 a day and your financing you're paying $800 a day for this thing, you're actually net $200 on day one. So now your ROI is like zero, right? Your payback time is zero, it's instant. So the financing is also making automation more accessible too.
We'll take questions now from the audience.
So I've been running a power business for a number of years, but I can't help myself from listening to this. I grew up in manufacturing in GE aircraft engines, ran some of their aircraft engine plants with VP of manufacturing for their Allied Signal aircraft engine business. Had a lot of experience with automation. One thing that was tripped us up everywhere we tried to automate, we had success, we had a lot of failures, and I don't think it would change today, is one thing that wasn't mentioned is quality or producibility of product. The biggest thing that tripped up automation was, as I learned from my Toyota system friends back in the early 90s, you can't automate something that's not repetitive. And what's happened over the years as designers and manufacturing engineers and manufacturers have frankly not gotten closer, in many cases drawn apart, if you don't have a repetitive process that can get good yields, it's hard, almost impossible to automate. So the positive way to say it is, low mix, high volume is really the biggest challenge there, because very often, unlike the automotive industry that pays very close attention to the repetitive or producibility of everything they put in a car, very many low volume, high mix production companies don't pay a lot of attention. So now you try to automate something and 2 out of 10 pieces fall out, or 3 out of 10 pieces fall out. I'm seeing some of the guys nodding there. That'll cause the wheels to fall out. So if you have good customers and you're a manufacturer, fantastic. And they understand that, it's easy to automate that process. But if you have poor yields, I found the biggest barrier, I agree with what was said, the biggest barrier can be the people, but often the jobs that were automated or are automated, many times when people say, shoot, I couldn't stand doing it anyway. So if they're bad environments and they're repetitive and they're boring, go have at it. But the real challenge is if you can't get good yields and you automate a bad yield process, it's just, you have nothing. So that's my 2 cents. I'm curious of what the panelists think about what I'm talking about, which is process yields.
So I think you have to start looking at processes and systems, right? So when you're looking at, from an engineering standpoint, putting my engineering hat on, right? Typically what we say is when you get an order, what is your new product introduction process in the organization? What is the level of FEMA you're doing to make sure that your production process within your company is robust? So now you're getting into the quality system side of things, right? So there's a whole, we're talking about automation, but there's a huge, it is not that you just come in and automate. There is a systematic way to do it. You need to make sure that your manual processes are working, first of all. If the manual processes aren't working, you have no business investing in automation, right? So it's not something that happens overnight. It's a long journey, right? And if you're expecting results tomorrow, no. But this is a 5, 6, 7, 8-year journey. And a lot of companies don't have the patience for that, right? But if you look at the long-term value, it's fantastic.
Yeah, so I just want to make one other comment. It is a strategy, it's a philosophy of the company. When I started out in GE aircraft engines in the early 80s, I have gray hair by accident, literally the product designers were really measured on performance of the engines. They had to be lighter, quieter, and so literally you could have a conversation with a design engineer and say, hey, this process is lousy. I literally have reworked 10% of my, 15, 20% of my parts. The response would be, well, what's the cost of that? I need to do it. You need to make it this way because otherwise I don't get the performance I'm looking for. So manufacturability has to be a priority, and as you mentioned, the whole system. So you in fact can have good yields, so in fact you can. Over time, people started to get it, but many of you may have customers that don't get it. It's really challenging.
I was just going to say that this reminds me of a conversation I had. There's a company out of, I think it's Golden, Colorado. It's called Vectus Automation. They build these little automated welding cells. They use a collaborative robot. And I was working with him and I asked him, how do you spot like a good application? So one of the questions you should ask is, are you a welder or are you a fitter? And what that really meant is, are you doing repetitive, simple welding, right? If you're making the same tractor part all day, every day, and this was a good welding task to automate. If you're building some sort of complex, piece of aerospace equipment, automating it could present a lot of risk, right? Because any sort of quality issue is very expensive. You're scrapping material, you're reworking. And so I think you hit the nail on the head. You need to choose the right application, something that is going to be easy to repeat. Don't start with the most complex thing on your factory. Start with, sometimes it's just go to your shipping and receiving department and use a robot to stack a pallet of boxes. And you're still saving a bunch of labor right there versus going after the most complex thing in the factory. So application selection.
I think another interesting point you just brought up was around this like collaboration between design engineering and manufacturing and the trade-offs. So I think that for small manufacturers, you have kind of this opportunity. I've seen a lot of manufacturers do this well, which is build this really technical collaborative relationship with their customers. In this case, it sounds like it was all under one roof, but I think in this context, we're talking about sort of the end customer and the manufacturer. And I've seen like a lot of, I think, machine shop type businesses sort of very scared to ask for any design changes or any relief on specs. But you know, the worst thing that can happen is really just no. And so the ones that are investing in really being creative and thinking about small technical changes, design changes, specs that could then allow you to increase your yield and maybe even change the way you manufacture something to automate it, to make it much easier to automate or to make it much faster, cheaper to manufacture otherwise is a huge opportunity that I feel like is usually missed. Because if you could remove that one little feature on one side of the part that would allow you to do it in one op and you could just run it, you know, lights out all weekend, that could make a huge difference.
Totally agree with that. And I experienced that at work too, where I will get feedback. And usually it turns out to be a better relationship because they appreciate the fact that I came to them with feedback and how to save money on parts for them. So very good point there.
And you know, but one more point. We've had many situations where driving that actually solved field problems because when you have manufacturing problems, you often have field problems with the same product. So more senior people who tend to realize, wow, there's a correlation here. We make the production process producible. In many cases, what's causing it not to be are flaws that can taunt you in the right side. So it's great to push back on that. I think there's so many dividends we get.
Yeah. Mark, I saw that you had a question.
Yeah, so I too, and I'll go to the second one, which involves AI. So we've got to a point where the hardware's gotten relatively, less expensive than it has in the past, and so that's come down. But still, when you talk to a small shop like yours, Christine, say, let's put a robot in, there's a cost associated with it. And with this high mix, low volume, part of the issue, I think, has been that what do you do when you have to change to a different part? Like, do they have somebody in-house? Do they have to bring in somebody from outside? So do you think there's going to be some sort of step change in the adoption of robots because that programming, that ability to be more flexible is going to come about either because of AI or maybe more of, I don't know if you pronounce it, RAS, robots as a service, where companies just come in, they've got the expertise to make changes quickly or maybe over air so that they don't have to come in the shop. Is there some step change that is happening in the next 2, 3, 5 years? Obviously AI could be one of them. That is going to make that hardware reduction in cost, AI, service models, the way you do it.
Yeah, I think you're hitting the topics on the nest. It's going to be a convergence of these different things. The key thing is to avoid having to go back to the system integrator to ask them to quote a new programming whenever something changes on your shop floor. Because if you do that, it's a 4-month process, you have to quote again, it's expensive, and that's it. You're missing the high mix story. So you need to remove that bottleneck. There are a few ways to remove that bottleneck. The first one is to automate the programming of the robot itself. That's done through AI. I'll give an example. Path planning, one of the components. Path planning is basically telling your robots to go from A to B. The way it's done traditionally is you code a succession of hard-coded waypoints. So say you start here, and then you go here, and here, and here, and here, and here, and here. So you code like 100 different waypoints that are a few inches apart from each other. If you have to do that every week, that's a lot of programming time. With AI, you have techniques, you just say you start in A, you end in B, and you avoid obstacles along the way. That's it.
Can you not do that with the current pivot tools or ways of just, it still takes a lot of time? Okay.
Yeah, it still takes a lot of time, And I give you the easiest example of path planning, but when it comes to grasping, you need to annotate the grasping point. Now, when it comes to insertion, that gets even more heavy. So the AI is very important. I think you mentioned 2 other things, the over-the-air. Sometimes you still need to call the system integrator somehow. If they can do an update over the air, quick fix without having to come in your facility and fixing things, That's also a huge time save. And the third thing, the business model. I think, Tim, you mentioned that. Robot as a service drastically lowers the cliff to start investing in it. So really three things together, plus the reduction in hardware cost. That's what removes the bottleneck of having to call your system integrator every time something changes. And as we said, like 5 years ago, it was not possible. Like the time is now. That's really getting possible in paybacks that are between 1 and 2 years.
Do you have any other questions? Connor?
So discussed earlier in the panel was how the U.S. is behind on manufacturing of robots. What do you guys see in terms of what's going to happen with the U.S. in the next couple of years with robots, and like how long is it going to take to catch up with the other countries? I know Europe is pretty big in that, and as you mentioned, China.
I think you said like manufacturing of robots, which the U.S. has been way behind for a very long time in. Like all the big robotics companies are Japanese and German mostly, right? Some Chinese. But then there's the implementation of robots, which I think is the stats that Christine mentioned earlier, which is where, China's like installing half of the world's robots every year. And we're, I think, not even in the top 10. When you look at like the key stat a lot of people reference is like robots per 1,000 whatever workers, right? Manufacturers. And we're not even in the top 10, which is pretty scary. I don't think, I have no like huge insight in terms of like macro economy where things are going in 2 years, but we know that in general, like we've talked about, like robots are getting cheaper. AI is going to fundamentally, I think, change the value equation and how robotics can be adopted and implemented. And I think it's up to us here to figure out like how do we build the business cases and really uptool, upskill, retool our factories, our facilities to make sure we can really compete and win globally. And then like of course we'll grow, like that'll come. But yeah, a lot of changes.
At Intrinsic, we have an office in Mountain View, in Munich, pretty big office in Munich, and in Singapore. So we're kind of covering the 3 big geographies. And I think it's right. What we see on the hardware and the traditional robotics, the system side, the OT side of things, Germany, Japan is ahead. There's more talent there, the ecosystem is deeper. The advantage of the US is what we were just talking before. It's AI, software, this business model innovation. And that's actually the next frontier. Automating this high-mix low volume is not going to be done with better hardware. It's going to be done with better software. So the US is actually pretty well positioned to take advantage of that if they focus on software and AI. That's actually the way to go.
Yeah, this actually goes back to Mark. I think education is going to be a huge part too, as we have more and more young people entering the manufacturing force. If they have studied robotics in school or know how to program and can jump in and help, then I think that will help the whole country grow our manufacturing strength. So yeah, I'm just keen on supporting local education too. So a little plug for Mark and all the work he does.
I mean, I think we have a problem with legacy, right? We had the latest technology 30 years ago. The problem is shifting that technology takes a lot of cost. While, if you look at India or China or Korea, they are starting with the latest technology up front. So the cost of adoption is a lot less. For us, it starts today with folks like you, right? Talking about this, opening the eyes that it is not an expensive option, and then exploring and, seeing that it is usable, right? I know we got into automation because our business was almost going out of business. We were desperate to survive. So we were willing to do anything to survive, right? Most companies are making money and they don't want to change what they're doing because they're worried that it'll disrupt their organization, right? As opposed to proactively changing their organization. And that's the difference, right? China, they're not a democracy. They say, automate, you're going to automate. We have a democracy. We all have individual mindsets, right? And we individually make a decision. And that's the difference.
Totally. And I'll close with this. I think that it takes a whole village to disrupt this industry. Being in Silicon Valley, we are the hub of innovation. unfortunately, we are not the hub of manufacturing, and we really need to figure out how can we innovate manufacturing, starting with Silicon Valley. Like, we really need to just take that step forward, try new technology, and try to get ahead, because I don't think there's any other way but to just do it at this point. And Silicon Valley, a lot of software engineers, right? And I think that it's kind of pivoting now, where I hear in like Berkeley, they're enticing a lot of students to be mechanical engineers, more